let us look at measuring rates, right? And so I'm going to go one or two slides back, and as you can see over here, when we talk about measuring rates, this really depends on what the reaction actually is and what product actually is formed from that reaction, right? So let's go to the next slide. So here's examples of reactions that produces gases, carbon dioxide, hydrogen gas, and so forth. And these are just examples of different types of reactions. What we are trying to demonstrate is how you want to measure how much product is produced or how quickly the reactants are used up depends on what you're actually going to produce. So here's one example. This is known as a gas syringe system. A gas syringe system. Okay. And so this is one of the ways in which you can actually measure the rate of a reaction when a reaction actually produces gas. So here you can see we've got some reactants. These may be certain chips and so forth in a liquid, and that reaction causes a gas to be released. Now, instead of the gas escaping from the system completely, what we do is we catch the gas in a syringe. Now, as the gas goes up and it moves through here, what will happen is the gas will force the syringe to expand, right? And as time progresses, the more and more gas that's released, the more this syringe will push back and actually form how do I say, a load of gas that is actually in the syringe, right? Now, when the reaction runs to completion, that means it's no longer going to produce the gas. Then we can say that the syringe is going to stop. It would stop at some point, right? It stops over there, for example. And that's when you draw a curve, and that's going to be a horizontal line. The reaction stopped, the reaction ran to completion, and so forth, right? Now, if you haven't done calculus, this will sound foreign, but really the reaction rate depends on how steep the gradient of the graph is. Here it's very steep, so it's going to be the fastest reaction at the start. It gets less steep and less steep and less steep, and eventually it's a horizontal line with a zero gradient. And at that point, the reaction is actually stopped. So this was one example of how to measure the rate of reaction, how quickly that gas is going to form. If you have another reaction that is collecting gas, you want to see how quickly that reaction runs to completion, or how quickly that reaction causes the syringe to stop actually flowing, and pushing out. Okay, so let's look at another one quickly. Here's an example of the X method. It's a little X that you place below a clear beaker, for example. So let's say you have a glass like this. You can ignore the color, and let's say a precipitate has to form and you put an X below it. You could monitor the time it takes for that X to completely disappear, and of course a reaction where the X disappears faster than another reaction means that reaction is running faster, okay, or it's experiencing a faster rate of the reaction. Okay, and then another way in which we can also measure the rates, this says change in mass. The rate of reaction that produces a gas can also be measured by calculating the mass loss as the gas is formed and escapes from the reaction flask. So let's say you have a container and it's the same flask that we've seen earlier. Instead of having this syringe on top in which you collect the gas, you could simply just check what mass is lost per time unit to check the rate of the reaction for the gas that is escaping. And of course, once the mass remains constant of the lost mass, like you're losing a kilo and you're losing like a few grams, etc., you eventually end up you stop losing mass, and that's when the reaction has ran to completion. Okay, so it says here this method can be used for reactions that produce carbon dioxide or oxygen, but are not very accurate for reactions that give off hydrogen because the mass is too low for accuracy. Measuring changes in mass may also be suitable for other types of reactions. Okay, and so those are three basic ideas of how we can measure the rate of reaction. Now this section will be tested in your application of various questions in the examination that look specifically at application, synthesis, analysis, when you're given experiments and so forth. Okay.